What's going on, guys? This is Dave here with HDR Performance. What you're watching right here is an actual VCM Scanner data log playback through an 8HP transmission calibration. As the log moves, the software is following the accelerator pedal position, output shaft speed, and current gear. It is showing exactly where the transmission is operating inside the shift matrix and on 2D shift curves. The software can also compare the actual output shaft speed against the programmed target, so we can better understand whether the transmission is shifting where the calibration says it should. I built the HDR Performance 8HP transmission tool because tuning these transmissions can become complicated very quickly. Most tuners naturally think about shift points and engine RPM. We might say we want the engine to shift at 6,500 RPM or 7,000 RPM. But the Mopar 8HP shift schedule inside of HP tuners is based on output shaft speed. That means every engine RPM target has to be converted using transmission gear ratio before it can be entered into the shift schedule. Once you start working with minimum upshift RPM, maximum upshift RPM, downshift limits, part throttle behavior, different gear ratios, and 14 separate shift columns, there's a lot to keep track of. The goal of this program is to make that process easier to calculate, easier to visualize, and easier to analyze. This software supports both generations of the Mopar ZF 8HP family. That includes Gen 1 and Gen 2. The correct factory gear ratios are already built into the program, but the custom gear ratios can also be entered for applications that use different internal setups. The basic workflow is pretty straightforward. First, choose the correct transmission generation. Then enter the engine RPM targets you actually want. The software converts those targets into the correct output shaft speed values and generates the complete 8 HP shift matrix. The calibration settings are separate into collapsible sections, so you don't have to look at every control at once. You can open only one section that you're currently working with, and the entire calibration panel can also be hidden when you want more room for the matrix graphs. Minimum upshift RPM. Minimum upshift RPM controls the lower pedal end of the curve. This determines how long the transmission stays in each gear during light throttle and normal driving. The software then builds the part throttle curve, the minimum and maximum targets while following the selected strategy and reference table shape. Downshift targets. The downshift control works in a similar way, but they are looking for the resulting engine RPM after the transmission moves into a lower gear. Maximum downshift RPM helps prevent the transmission from requesting a downshift that would put the engine above the RPM limit we are comfortable with. Minimum downshift RPM helps shape the low pedal downshift behavior. These values can also be controlled globally or adjusted individually for each gear change. Importing the stock HP tuners matrix. One of the most useful parts of the software is the ability to start from the vehicle's actual stock or currently modified calibration. In HP tuners, select the complete 8HP matrix, right-click and choose Copy with Access, then return to the program and open the reference matrix editor. The full Copy with Access block can be pasted directly into the editor. The program reads all 12 accelerator pedal position rows and all 14 shift columns. This gives us the original pedal access with the original OSS table shape to use as the calculation base. That is important because we are not forcing every transmission into one generic curve. We can retain the shape and behavior of the original calibration while adjusting it around the new RPM targets. A cool little bonus that we have added to the software is you can enter your own final drive ratio, so your rear diff gear ratio. You can also enter your tire diameter, and then these values can be seen also as vehicle wheel speed targets. So you're going to see at what speed the vehicle is actually trying to shift. And you can also do the same up here on the drop down. You can go calculated engine RPM. So these are the engine RPMs that you're referencing on the shift point. Also, when you're done with the project, say you have something set up the way you want it and you want to reference that project in the future very easily, or you're tuning multiple vehicles and you need to be able to save your transmission build so you can just quickly go back to fine tuning on changes. You can go up here to save transmission tune. Select the appropriate save location. Typically, I would recommend saving it in the tune folder that you've built with HP tuners that you're saving the customer's data in. And that way, when you're done, you can just go to open, find that calibration file, open it up, and resume where you left off exactly. The only thing is, it's not going to automatically load the previously loaded CSV file. You're going to have to open that if you're trying to use the Datalog function to reference. If you're confused on how to get a log to work correctly with the software, you can reference the help section, VCM setup and help, and it will show you how to run through the steps. These are going to be recommended PIDs that you can log. It's going to show you the list for your transmission. And then you're going to come over here to log file, export log file, and then you're going to choose the CSV file format. I'll show you really quickly as an example. So we have a demo log pulled up right here. We're going to go log file, export log file, and we're going to choose comma separated text in the CSV format. Entire log, you can or cannot use this as an option if you want to. It'll interpolate the data between any data points that are missing. You click export. We'll go test. Open up the software. Load CSV log. And now that log is uploaded for review. What's really cool is in the log section, you're going to get the graphs of everything you need, but it's also going to show you the exact shift it's marking. So every time it shifts, you're going to see a designated line showing what shift it is, 2 to 1, 3 to 2, etc., etc. And in that log process, you can do your compare shift. So in the shift that it's currently in the log, you can see what you have programmed, which is the neon line, versus the dotted line is what's in that calibration for the transmission. As you make changes, you can get a visual representation of what you're doing and how the shift graph curve is starting to look. You also can do curve overlay, and you can do it on upshifts only, right? You can do it on downshifts only, right? And it's also, like I said, still referencing what gear it's in during that process. You also have the ability to view all upshifts, and it will still highlight the current gear it is in the CSV log.